This work entitled "Can Planning Mitigate Urban Heat Island?" A remote sensing and local climate zones analysis for Barcelona has been developed by researchers of the Center for Land Policy and Valuations. Specifically in the context of the project Urban Clean Plan, Urban Heat Island, Effects on Climate Change and Modeling Towards Strategies of Territorial and Urban Planning, application to the metropolitan region of Barcelona. The warming of the climate system is unequivocal, and since the 50s, its anthropogenic origin seems a fact too. Cities have a special role in climate change, basically considering two main factors: the urban generation of GHG and the radiation generated by the surface of the urbanized land. Although the climate of cities depends mainly on factors of regional character, local and microscale factors can modify the regional climate, generating urban microclimates. In this context, the urban heat island describes the influence of urban surfaces on the temperature patterns, in contrast to the surrounding areas. Urban planning has a fundamental relevance to coordinate and implement measures to improve the climate quality of cities in the face of global climate change. But currently, on the larger scale, the regional and urban planning are developed only a few initiatives to adapt it in order to increase urban resilience to climate change. In this context, the main objective of this work is to study how urban planning affects the generation of the urban heat island in the metropolitan area of Barcelona, as well as the determination of local climate zones, using remote sensing techniques. The specific objective is to integrate the evaluation of the urban climate in the metropolitan planning of Barcelona. The methodology combines remote sensing and the analysis of attributes that characterize different urban areas. The combination of both allows the construction of the local climate zones. The first step of the methodology is the remote sensing analysis at metropolitan scale. The land surface temperature is obtained from Landsat 8. Then, some indexes that affect urban heat island are obtained. And finally, the LST and the other indexes allow a detailed approximation of the urban heat island. The second step is the local analysis. In this one, the following indicators has been analyzed: albedo, sky view factor, aspect ratio, etc. Finally, the integration of the previous indicators with the obtained data through remote sensing allows obtaining the local climate zones of Barcelona. For obtaining the daytime LST, the numerical coding of the thermal band has been converted into physical units. Once finished this process, the urban heat island for the metropolitan area of Barcelona is obtained. Considering that the resolution of Landsat does not allow the detailed knowledge of the LST, a method for improving the spatial resolution is developed. A geographical model in the first step, then an urban model, and finally, with the integration of both, an hybrid model is developed. This explains 64% of the spatial variation of the LST. For obtaining the nighttime LST, the most relevant data to know the urban heat island effect is used MODIS information. In this step, it is possible to make a comparison showing the differences between the morphology of the urban heat island in day and night. Once obtaining the LST, we know the urban heat island by uses. The hottest uses are logistic activities and industry, and the coolest, rural areas, basically of protection, and green areas. In summary, artificialized areas show an average LST set point 2 higher than non-artificialized zones. Once confirming the existence of an important urban heat island, it is convenient to propose measures aimed at refreshing highly artificialized covers by the introduction of local climate zones in urban planning. Finally, the combination of the LST with the other indexes allows the establishment of the local climate zones. The methodology differentiates the following categories: urban fabrics and open spaces. In the elaboration has been overlapped different information sources: Metropolitan General Plan, Corine Land Cover, blogs, ST, NDBI, and NDBI. One of the analyzed areas is Viladecans-Gavà and Castelldefels urban continuum, and here has been compared the obtained climatopes with the LST. In the analysis, is detected that the hottest climatopes are city and inner city, and the coolest, forest and dense forest. Some conclusions. The study carried out allows to know the climatic behavior of the different land uses, as well as to elaborate criteria that increase the efficiency of urban planning. In synthesis, we can conclude that the use of both analyses can help to identify general and specific areas of the urban heat island, and the urban morphology and land uses play a key role to generate and control urban heat island. Thanks for your attention.